Hello everyone and welcome to 3.2. I'm going to split 3.2 into two different set of notes. In the old book it was two different sections, and I think it goes better if it's listed as two different sections. So today we're going to talk about the first half of 3.2. So I'm going to call it 3.2a, Implicit Differentiation. Up to this point, most of the functions that we've dealt with have been in explicit form. Explicit's what you're used to, y equals. But they don't have to be. They could be in implicit form. Implicit just means that the x's and y's are all together. Notice that these two functions are the same. They're just different ways of writing them. Explicit functions are set to y equals. Implicit, not necessarily y equals. To find the derivative, we're going to rewrite by solving for y, but that does not always work. For example, in this problem, well, I could subtract this guy over. 2y cubed plus 4y equals 2 minus x squared. But now I have two different y's. I can't get just y equals. I cannot write this function as an explicit function. I need to know a different way to take a derivative. Implicit differentiation. When we have a function that cannot be written explicitly, we have to do implicit differentiation. But remember, we're still doing it with respect to x. Now what do I mean by that? We're still going to treat the x's the same. Anything with an x in it, we're going to take the derivative just like we normally would. Anything that has a y, we're going to do the chain rule. Because y is a function. Well, what is the derivative of y? The derivative of x is 1, but what's the derivative of y? Y prime. Anything that has a y with it, we're going to treat it the same as x, but we need to include a y prime with it. And that will make sense as we're doing the problems. So that's how you do implicit differentiation. Treat the x's the same, treat the y's like x's, but include a y prime. That's just taking the derivative, but then what do? Step 1, take the derivative, just like we talked about. Step 2, get all the dy's or the y primes or anything that has a y prime in it on the left side. Everything else goes to the right side. We're going to factor out the y prime, and then we're going to solve for y prime by dividing both sides of the equation by the left-hand factor that does not contain y prime. Sorry. It'll make sense when we do a problem. Okay, let's try this one. Notice that y is not a function of x, but I can still do it. So let's take the derivative of this guy. Well, what's the derivative of y cubed? If it was x cubed, it would be 3y squared. Anything that has a y with it includes a y prime. Plus, what's the derivative of y squared? Well, that's 2y. Anything with a y with it is y prime. What's the derivative of 5y? 5. Anything with a y, y prime. What's the derivative of x squared? 2x. What's the derivative of negative 4? 0. Now my rule said get everything with a y prime on the left side, everything without on the right side. Well, that's pretty easy. The only thing that would move is this negative 2x to make it positive 2x. My next step is going to be to factor. All three of these terms have a y prime in it. So y prime, pull it out, leaves me 3y squared plus 2y minus 5 equals 2x. Now my last step is to get y prime by itself, so I need y prime equals. So what does y prime equal? Well, it's 2x divided by this parenthesis, 3y squared plus 2y minus 5. And that's an implicit differentiation problem with the x's and y's all mixed together. Now let's stop a minute and think about what we just did. We took a derivative, but what does a derivative do? Derivatives tell us slope. So at the point 2, 0, what's the slope? Well, 2 times x is 2 over 3 times 0 squared plus 2 times 0 minus 5. What's the slope? It appears to be negative 4/5. So I could do a tangent line because I have a point and a slope. At 1, -3, the slope is, well, m equals 2 times 1 over 3 times -3 squared plus 2 times -3 minus 5. Ooh, that's going to be, I have to do a little bit of math here. That's 2 over 27 minus 6 minus 5. That's 2 over 21, 16, I think, just 1/8. So at 1, -3, the slope is 1/8. Implicit differentiation is still differentiation. It's still a slope. So let's try this now. What is this asking me to do? What am I trying to find here? What does this symbol mean? It means second derivative. So let's find the second derivative. I can't find the second derivative until I find the first derivative. So let's take the derivative. What's the derivative of x squared? 2x. What's the derivative of y squared? 2y. I took the derivative of something with a y in it, so it's y prime. What's the derivative of 25? 0. Get everything with a y prime on the left side, get everything else on the right side. Factor out, but I don't need to factor. Y prime equals negative 2x over 2y, which is equal to negative x over y. So this is my first derivative. But now I need the second derivative. So let's just take the derivative of both sides. What is the derivative of y prime? Y double prime. Oh look, that works out. This is not negative 1 over y prime. It's a division problem. When I have a division problem, I have to do quotient rule. Quotient rule says bottom times the derivative of the top minus the top times the derivative of the bottom. But what is the derivative of y? Y prime. All over the bottom squared. Cleaning this up a little bit, I get y double prime equals negative y plus xy prime over y squared. Sadly, I cannot leave this answer like this. I have a y prime in here. I can't leave the y prime. What is y prime? It's negative x over y. So, this is equal to negative y plus x, negative x over y, all over y squared. Got to clean it up. Got to do some complex fractions here. On top, negative y plus, I guess that'd be minus now, minus x squared over y, y squared. I want the top as one fraction. The common denominator is going to be y, so I got negative y squared minus x squared over y times over y squared. If you have trouble with finding a common denominator here, come talk to me, but that's something you have to be able to do. Dividing by y squared is the same as multiplying by 1 over y squared. So that'll make negative y squared minus x squared over y cubed. And that's your final answer. Now if you want to, what you could do to make this a little bit prettier is you could pull the negative out and makes it y squared plus x squared over y cubed. And if you really want to make that prettier, you can call it x squared plus y squared over y cubed. Any of those answers is fine. This answer is completely fine. It doesn't have a y prime in it. Let's back up a minute. I did implicit differentiation. I got the y prime by itself, and I simplified to get the first derivative. I did quotient rule to get the second derivative. But the second derivative has a y prime in it, and I cannot leave the y prime in it. So I got to put the y prime back in. Then the rest of this problem is just cleaning up your fractions. And then down here, it's just rewriting it to make it whatever matches. The only thing that worries me here is a multiple choice test. You might get this answer, but the multiple choice test might have this answer. Just knowing that they're the same thing. And that's it for implicit differentiation. Again, if you have trouble with this, come talk to me. We'll do many more examples in class. But other than that, thanks guys.